Welcome and thank you for joining us this afternoon. My name is Duncan Retson. I'm with Public Services and Procurement Canada. I'm very pleased to have you join us today and have the pleasure of being joined by a number of esteemed colleagues today for this pre-conference panel, A Call to Action, Sustainable Design Leads to Better Science. Appel à l'action, la conception durable mène à une meilleure science. Before diving into the session, I'd like to take a moment to acknowledge that I'm joining you today from Ottawa, the traditional and ancestral lands of the Anishinaabe Algonquin Nation, who are stewards of these lands and the Kitchissippi River and its tributaries. We pay respect and we honor the Anishinaabe, who have a long history of welcoming many nations to this beautiful territory, who have nurtured this territory and continue to be the caretakers of these ancestral lands. I would like to introduce now those who have agreed to join us for this discussion today. Very honored to have with us. Oh, sorry, was somebody coming in there? No. Very honored to have with us here today some distinguished folks who know far more about the topic than I do. We have with us on the line, we'll see, Ms. Carol Phillips. She's one of our panelists, and she is a design leader and a partner with Moriyama Tashima Architects. Thanks, Carol, for joining.
Thank you, Duncan.
Good. We have Dr. Ursula Eicher, Canada Excellence Research Chair in Smart, Sustainable, and Resilient Cities and Communities. She is based at Concordia University in Montreal. Welcome, Dr. Eicher.
Thank you, Duncan.
We also have with us Ted Kezin, Professor of Building Science and in the John H. Daniels Faculty of Architecture, Landscape, and Design at the University of Toronto. Welcome and thanks, Ted.
Good afternoon, everyone.
Et on a Dr. Annie Laverselle, professeure de génie de l'environnement au département de génie de la construction à l'École de technologie supérieure à Montréal. Merci, Annie.
C'est plaisir.
Oh.
Okay, so we have a series of questions here today that we're going to discuss as a panel. But what we're really talking about is, as I said in the title, the idea of this call to action about doing good design. You'll see a poll will pop up there. We invite you to participate in the poll as we go along. So why are we really here? I guess at a high level, obviously, for this audience, you needn't be told, but I'm going to anyway. Science plays a key role in supporting a vibrant society and a thriving economy in Canada. However, the laboratories today that are supporting our major scientific advances, from medical breakthroughs to insights that keep our environment clean, they use tremendous amounts of energy and they generate considerable waste and greenhouse gas emissions. Ce panel est un appel à l'action en faveur de la conception durable en tant que norme future pour les environnements de travail des laboratoires et des installations de recherche. La conception durable des laboratoires peut contribuer à améliorer la science et le lieu de travail des scientifiques en favorisant l'efficacité énergétique, en améliorant la qualité de l'environnement intérieur, en réduisant les déchets, en conservant l'eau, en encourageant la collaboration et en intégrant des éléments de conception biophilique. By creating sustainable and healthy work environments, labs can actually enhance science research, productivity, and the overall well-being for scientists. So in that spirit, Emil, the first question that I'm going to put out speaks around plausibility of the vision. So the International Living Future Institute asks, what if every single act of design and construction made the world a better place? Chris Turner, in his book, How to Be a Climate Optimist, also posited towards change that is not just less bad or good, but that can actually better the lives of individuals. However, labs in Canada have often been given an exemption, even from energy efficient or water conserving measures in aspects of their design. So, by virtue of your agreement to participate today, I know that you agree on the plausibility of more sustainable practice and that it is possible to have healthy and safe buildings while having a positive effect on the environment. Nonetheless, some labs and research facilities, it does seem like enhancing those surroundings is kind of something out of science fiction, if you look at the starting points. How far do you believe laboratories and research facilities can go in being sustainable and regenerative? So I'm going to ask Carol to weigh in on this, and then I'll see if Ted has some thoughts. Carol.
Yes, thank you, Duncan. I mean, I think it's a great question because there's a number of specialized types of buildings that that look down the sustainability route in terms of the measures that high performance buildings are doing, regenerative buildings, and think, well, you know, what we're doing here is far too specialized to be able to partake in some of those systems. And I think when it comes to laboratories, I think one of the things you want to do in terms of reassuring the occupants of the building is that the primary function of the building is research. And there has to be a way to be able to protect that research, make sure that it is sound and unaffected by and unencumbered by such systems, say as natural ventilation, et cetera, that could actually impact or vibration that could impact the nature of the research. However, like most complex buildings, it's not a singular activity. There's places where people are doing written work. There's places where people are actually convening to meet. There are places of social and collaborative environments that are not necessarily required to be that controlled. So I think that this idea of compartmentalization and this idea of strategically looking at the spaces that can be have a different criteria than the areas that are required to have certain stringent environmental conditions would allow for the protection of that research, while the majority, and you'd be surprised to know that a lot of the majority of those spaces will not require that kind of stringent applications. And I think the time is just far too late for us to say that, oh, well, you know, to throw up our hands and say that, you know, we can't do anything because of this. There have to be ways that we can each approach this. The time is running out quickly. And I think compartmentalization is actually one of the major aspects of doing so. And I know that the government is involved as well, like, for instance, the facilities in Chalk River, where entire facilities perhaps are built of one type of construction, but then other facilities that are just more administrative are entirely built out of biomaterials and do not have the kind of vibration criteria that the other spaces are required to do. And then, of course, there is the responsibility to the entire site. And so beyond the buildings themselves, because we can't think about this as just buildings, just as we can't think of ourselves within all our four property lines, we have to have systems thinking about how we are approaching how we power, heat, and how we impact the land and the stormwater management around all of our construction projects, because we're not singular items. We're actually completely related to the other environments we're in. So maybe I'll just stop there for a moment and see what Ted has to say.
Yeah, totally agree with what Carol has been pointing out. I think when we had sort of what I call the old world view of laboratory buildings, they were sort of these isolated enclaves where there were these rigid standards applied to every square centimeter of floor space, and people were supposed to sort of go in there and behave much like robots rather than people. But I don't think that's the world of 21st century laboratories. And so the compartmentalization issue is the key. And so if we think of everybody that has a lab as that lab being a community, and then if we think of those being nested inside of a building that is actually allowed to swing a little with the variations in temperature. In other words, a space that is not so tightly controlled, but has access to light, air, there's biophilic elements in it, possibly plantings, and so on. We have the technology today to be able to take those particular lab communities and isolate them adequately, but we don't have to do that to the entire building, and we certainly don't have to make it so the building is not connected to its community. So I think those are sort of the nesting strategies that we have to move towards, instead of having an either or black and white sort of a division. It has to be this sort of a phasing in,
Oh, I think we just lost you on a mute there, Ted.
Oh, I'm sorry. Anyway, I think the compartmentalization issue really is something that we have to explore a lot more.
Great. Ursula.
And just little addition. I mean, you asked, is every building important? And I think yes. I mean, we are in a climate emergency. We need urgently some front runners, and I think the scientists are very well suited to experiment. They're used to experiment. So to put in all the smart technology in buildings, to have occupant-centric control and all this, the renewables, the load management, all the stuff that we've been talking about, we need to start implementing it in every possible building. So I would say yes, every building counts, and these ones are particularly suited. I mean, especially maybe even the ones who deal with energy or climate research.
It's a great point that picks up on the title of this, a call to action. You're challenging the folks on this in this session to be leaders in the way they embrace the new technology in their spaces, as well as those of us who think about what those spaces could be. A bit of a symbiotic relationship there if we all push in response to the emergency upon us. Thanks for that.
I would just also add that, in a lot of the buildings that we're doing now, the building is the subject of research. And I think that this is a huge opportunity in discerning how we live in the climate emergency.
Yeah, it's an interesting idea. The idea of the lab aspect of the building itself as a bit of an experiment as we push the envelope in, certainly in the case of the federal laboratories that I know fairly well, very staid and stoic structures from a different time, many of which were never actually intended to be laboratories. Some of the scientists with whom we work are located in old office buildings, in old industrial bakeries, in old convents. Like we have quite a range of building stock that is probably not what one would. It probably doesn't align the best with the thrust of our discussion today. If you were imagining how would you design something to demonstrate the kind of leadership that Ursula just spoke of in terms of the facility, but thinking about it in terms of its opportunity to provide leadership as a structure to enable science and embrace doing things differently. I'm going to shift I'm going to risk being a downer. I'm going to shift the questions a little bit here on this next one as one of the signs of the times. And I just realized, very rude of me, I'm joined here in the room by Mark Potter, who you'll see on a split screen with me. Marc est directeur principal de notre groupe qui s'occupe d'innovation et quelques aspects d'engagement avec notre programme de Laboratoire Canada. So thank you again for joining us, Mark. Mark, along with Elizabeth, who you may see on the list of people, is have been one of the forces behind bringing this group together. So that's who Mark is. My apologies, Mark, for not sooner. But from the sublime to the less happy. So when you think about design challenges, and you think about labs, that for the reasons that we just spoke of in the last question, very specialized infrastructure, but in fact a series of infrastructure, compartmentalized, and at the same time somewhat perhaps more free in design than we've conceived of it traditionally. Putting all of these things together, doing it within a budget is in and of itself, I think architecture in and of itself is always an exercise in constraint. It's creating really great spaces that work really well within some design parameters or limits. The current economic context is one that imposes a need right now when we're talking about public funded infrastructure for a degree of fiscal restraint. And it's not really, well, it is a Canadian situation, but it's certainly not a situation unique to Canada by any stretch. Our recent federal budget at the same time, which is our core fiscal document, it also introduced a way forward towards net zero emissions, including things like regulation of clean electricity, new standards to set performance requirements for facilities. So the way that we procure them, the codes that govern their construction, and the adoption and preparation for more electric vehicles. So we've got a couple of things going on at the same time. We've got the idea of fiscal constraint, but we also have measures that are designed to what Ursula described as the climate emergency. So there's a couple of other elements of constraint together that inform design. So architects are at their core, I believe, very creative, and they're able to work with changing requirements to create spaces that respond for their clients to their times. But designing with more restraint, it can mean changing some of the areas that have long traditions found in certain indoor spaces. So I'm thinking of things like, this is my office, dare I say, this is my parking spot. Certain workflow processes about everyone has their own lab with their office in the back and their own particular equipment. In many cases, however, it starts smaller. That kind of change that can be driven, and it provides some incentives or good options for people to imagine working in new spaces, which may involve sharing or collaborating. But these changes themselves beyond facilities can be tricky. So I guess my question is, when you consider the constraints from a few different angles for good reasons, and what that means in terms of thinking about new ways of designing, but like working in and being in these new spaces, what are some of the underlying drivers that make it tough for people to adopt to these new spaces, whether the sustainability policies or sharing, we could call it? And how would you say we should think about or approach these kind of concerns or overcome any barriers to think about moving into these new spaces? It can be things like our policy frames, our regulatory frameworks that govern how we do things. It can impact how we look at planning projects, or it can look at how we actually sort of execute delivery. So any thoughts for people on the panel in terms of working in a constrained environment that's pushing us to go in new directions that may be unfamiliar, and just from the unfamiliarity, like almost a little bit uncomfortable? As people who think about this, how would you encourage us to approach these problems as users or designers of new types of spaces? Ursula.
Yeah, I can make a start. I mean, I would make 2 points. I mean, one concerning the fiscal restraints. I mean, if we talk about sustainability measures, whether it's new build or retrofit, I think the main point would be to very consequently look at life cycle performance, because very often these sort of higher investment costs at the beginning, higher upfront investment, they do pay back. I mean, okay, there are some provinces in Canada that have very, very cheap prices, energy prices, but in most places there's a net present value. So if you just combine the upfront investment with operational cost, you usually get a return on investment. And so that's the first point. So there's no contradiction really to build more sustainably and be cost effective if you consider life cycle costing. And the other point, I mean, on the spaces, I mean, I moved to a very open space here with the Next Gen Cities Institute. I think the main point is flexibility in space use. I mean, in the last years, we all seen tremendous changes in the work environment. Many traditional spaces are pretty empty. And it's actually coming to a space that is pretty open, actually feels better because there's some people in it. It's not a bunch of empty offices. So I think that there will be an adaptation needed anyway, because the whole working environment has shifted. And if these open spaces are flexible and offer some room to retreat and have meetings, so to have a possibility of moving between this openness, which some people don't like, but and give them the space to retreat, to work quietly, or to have meetings or calls. So if flexibility becomes one of the key criteria, then I think it will work, because everybody will find their space in a much more open, flexible setting.
A great point. Carol, and then Annie.
Yes, sorry. I would add to that and say that I completely agree on the life cycle cost analysis. We're doing a lot of work with clients now to actually validate their decisions, to actually start moving to, in some cases, to look at, say, intensification of existing buildings, to understand if using biomaterials that are lighter, like mass timber, then traditional concrete or steel would give them more square footage. So there's like not only energy use and energy consumption, but there's actually square footage analysis as to what is possible when you're using different systems and lighter materials. And then once you push past the sort of the value analysis to look at the operational costs over a period of time to see what the payback time is, once you've reduced the energy consumption in the building, oftentimes what we find when we're working in these high performance buildings is that it's the lighting loads and the plug loads that are actually driving the energy consumption more than anything else. So now it becomes a game in a way of changing culture, to understand, to teach people not only how to work in different working environments, but maybe to expand their expectations. Is it looking at a thermostat and looking at the number and saying, oh, we've just shifted past this one number, but to actually question, am I comfortable or not? Simple moves like putting ceiling fans in buildings. Everybody knows that when you put on the ceiling, the fan, it doesn't change the temperature, but you feel more comfortable. And so if you can push the degree tolerance a little bit more and actually, think about changing culture in that way, and changing expectations for rote kind of responses to what makes you comfortable. I think that is the challenge. And I think if you can make really positive environments that are fresh and healthy, then perhaps people will put up with a little bit of a half degree or a degree change on the thermostat. But that's something that I wanted to mention.
Thanks, Carol. Annie.
I absolutely agree with what Carol and Ursula just said, and I wanted to add something about this concept of resistance to change. Of course, when you look at the whole challenge that we are facing, of course we will address this challenge with some solutions that are more on the technological side, and these ones are maybe a little bit easier to implement. Of course, there are still people reluctant to change, but still it's not as complicated as maybe the second family of changes, which require more behavior change. The example of the temperature comfort and the how you react to the the temperature, but we can think, as you gave an example about different models, if you want to share equipments or share spaces because you really want to optimize all the material and the energy that you use, then you might face more reactions of resistance. I think one thing that is key is to design the buildings or design the spaces involving all the stakeholders. That's very, very important, that if people participate to the design, they will be much more volunteer to this change. And we also have to make all these new models or new ways of doing things attractive. And we often give examples with transportation. Of course, like biking can be attractive, but of course it depends of all the infrastructures that favor the security or favor the that makes it a much pleasant experience. So that's the same with building or with sharing equipments and so on. So we really have to keep in mind to make these things attractive and involve the users while designing them. I think that's very, very important.
Very good. Ted, you looked like you were about to jump
I
in.
was just thinking about how important it's going to be going forward to realize that we probably will continue to live in times of very rapid and massive change, because there'll be lots of disruptive technologies. And so it's so important to build in a tremendous amount of flexibility and adaptability into our buildings. They have to sort of become really some kind of armatures rather than fixed spaces that have what I would call hard boundaries, where then we end up having to go in and change things around. I think the churn rates in laboratories is what in many cases causes enormous life cycle costs. And so at first people say, well, it's an economical building, or it's even a very green building. But as you watch what goes on, all of the materials that they're removed and new ones brought in and things rearranged, and all of the time and energy that's spent on that, it's problematic. The other part that's very important to realize is just human productivity, things like staff retention rates, absence from work, of course, productivity. So when we talk about being regenerative, for some reason, people are always focusing on the building. I think we should focus on the occupants. How do we regenerate our occupants so that they stay in the best of mental frames of mind and attitudes, so that they work more productively, enjoy their workspace, are better bonded to their community. I just think that part has really fallen apart, while there's been tremendous emphasis placed on the actual technology. But really, I don't think a lot of the equipment really cares the type of an environment it's in. I would rather take a lot of my stuff and put it in a dreadful environment just because it is a computer. I don't think it has feelings. I just think these are examples of how we have to completely rethink the fundamental premise, right? Of how
I can't help but observe the delicious irony that immediately after Ted saying he could put his computer in a dreadful environment because it doesn't have feelings, he froze. So, Ted's world of rapidly changing dynamic environments, technological change, AI, I don't know. I think the future is now, it's upon us. Hopefully, the computer feels better soon and allows Ted to rejoin us. But I do think that one of the main, there you are. So Ted, I was just observing that your computer that doesn't have feelings immediately cut you off as soon as you finished saying that sentence, which is quite delicious.
Well, I forgot to mention that my computer, of course, is different than everybody else's.
Yeah,
so
that's true. That's good.
Okay.
Great points all. So I think that one of the key answers in terms of thinking about where Ted was going about like the humans and placing humans at the center. And I heard this, I think, in all of your answers was, the people who are going to be in these spaces have to be at the center of thinking about how we design them and have to have a role and participate in helping design them and create spaces for humans, more than for spaces or even for functions. And that leads to a more effective usage of that space by the actual human beings who work in them. So designing spaces as we did back in, at least I'll speak in our own case, for some of our federal labs, designing them for isolation, specificity, and rigidity back in the 70s are probably not the pillars of design you'd speak of now when we think about what do we need in labs going forward to meet the requirements of human beings who work in them and will for a while. Next question, I think, very much picks up on that theme. And it's the idea of how buildings respond to users and users' needs. So sustainability is present everywhere, but so much so it can almost become invisible. Smart buildings can make some impacts more visible by doing things like displaying real-time energy usage. But this type of visibility speaks to mostly a subset of technically minded individuals who have an interest in their buildings. So perhaps there are some of those on this call, but a lot of the people who work in buildings just want the buildings to work well and to help them work well in them. So it doesn't, that kind of data about, the energy usage in a building, it doesn't, for example, reveal the work that went into a very efficient building envelope that also creates that kind of space that people want to be in. I had the chance to tour a great laboratory in the UK that was a very high containment level biocontainment laboratory that deals with some extremely nasty pathogens. There were lots and lots of windows in that brought light inside that space. It did it very safely. It was a very modern, contemporary design, but it created a more welcoming and livable environment for people who have to work in what is fundamentally at the bottom line, still a hostile environment. Good design wound up making it a lot better for people, and it was a place that people were happier to be in. The design actually encouraged collaboration as well, and it permitted cohabitation of different people working and seeing and experiencing, but in a safe, efficient, and productive way. The Government of Canada, it has efforts that range from the Green Building Strategy of Natural Resources Canada to things like the Zero Emission Buses Initiative that the Canada Infrastructure Bank is leading. So I guess my question here is, how should designs be evaluated, less in terms of like the building and more in terms of meeting the needs of the occupants who work inside a sustainable and healthy space? What things have you seen? What information do you have that makes more sustainable choices that respond to user needs, rather than being like almost an inconvenience? Sometimes it feels to users in these modern buildings. So Ursula, did you have some thoughts on this?
Yeah, I mean, we talked already about the prime function of a building is to make the users feel comfortable. I mean, thermally comfortable, visually comfortable, and that first of all depends on the fundamental design that you just mentioned. I mean, having daylight is incredibly important for well-being, and I'm still seeing many spaces in university settings, research settings, where people don't even have a window. I mean, it's quite incredible to me. And also, I mean, talking about going maybe a bit more into the details, I mean, coming from Europe, where every heating is done with radiators, or even better with sort of radiative floors or concrete core activation, sort of very, very comfortable heating. And then coming to a situation here where everything is still air-based. I mean, I needed to move room for this meeting because it's a freshly retrofitted building. It's so loud, this air-based distribution, you can't feel comfortable in a building with such such system design, and even with the best controls. I mean, it's basically there are some flaws in some of the systems, and I think it's known what could be done to improve thermal comfort, but it's not really taken up at scale, I would say. Because if you have an old system or an old car, you might put the best sensors in it. It's still an old car on an old building. So if you talk about smart, you need to have the systems which are smart, which can be enabled to be smarter in the very first place. And then if you talk about occupants, of course, occupants are pretty different in their needs and requirements. I mean, especially if you talk about open spaces, I mean, it's a question of age and gender, and that temperature levels that users want are just not the same. So interaction with the building management system is pretty crucial to make sure that everybody can work in an environment that is suited to the specific needs. And I think we're pretty far away from that. There's a lot of talk on smart buildings, but not much done in practice. And sometimes back to the design part, I mean, buildings which are designed really well to make people feel comfortable. So sometimes simpler solutions and better designs can make life actually easier to then operate a building to satisfy the users. Yeah, so that's my main take.
Very good, thanks. Carol.
Yes, thank you. I think again, I can't help but think about, initially I mentioned protecting research, and I mentioned a couple of things. One of them was, air transfers and vibration. And it's shocking to me, again, these like sort of air delivery systems, which are noisy, they have vibration. Yeah, when actually, sort of radiant systems require a much lower temperature energy input to move water, and it's stable. So I think, some of the things that you're mentioning, Ursula, really just kind of come back to that sort of initial thing about how do you serve your users, their needs and requirements, and pick the systems that actually work for them. And I also think that the other part of this is actually, in terms of researchers, looking at the data of the utilization of the spaces that are actually there. So meeting rooms and kitchenettes and private offices. And, if you do the research on the utilization of those spaces, then the idea that you can actually make bookable spaces that you share not only reduces the overall square footage needs, but it also suggests that there's the possibility of collaboration and encounter. And so for researchers to actually see each other's work, to understand what everybody else in the building is doing. And, recently we did a project for TMU where we brought together researchers in urban water, food and nutrition, and basically, and the electrical grid. You can't think of researchers that are working on totally different aspects of the urban environment, but with the health of the city as our common understanding. And we had to do a lot of work to get everybody to share a meeting room, or conference room. And in the end, you realize this 20-30 person conference room is barely ever used. And so, of course, they could book the time. And I think that there is the possibility then of understanding how you can share research and have a really, like, a community. Ted, you mentioned earlier on, like, having a sense of your community. I think this idea that you are sort of sealed off from what's happening next to you is there's a possibility of enriching research, I think, if you have adjacencies in these shared spaces. And when it comes to controls, I think you actually have to give some agency and autonomy to the users themselves. And so, you know, I'm an advocate of not having the building do everything for you. You know, if there's a weather station on the top of the building that tells you that it's a good day to open your windows, you know, having that physical interaction with your environment, having a sense of control, I think goes a long way to creating a sense of responsibility too. You don't leave all the windows open in your own house. So if you're actually doing this yourself and not just expecting someone else to come along and shut it all up for you, then I think that you're starting to change culture at that point, and actually creating a sense of responsibility to actually impact the physical environment. And, you know, it's a sense of control for the users, but it's also a sense of responsibility that inherently kind of comes with that. Yeah.
Thanks, Carol. So again, I keep hearing, you know, in the answers, the users, the humans, the people, like that this seems to be a central theme. And perhaps our central failing traditionally has been to design buildings based on approaches and technologies that we're used to. That old adage of if the only tool in your toolbox is a hammer, everything looks like a nail. We're used to designing with big air handling systems, so why would we want an operable window? Perish the thought, Carol. But you know, if you think about, you know, where are the humans in this, and what are the other technologies that are, as Ursula said, perhaps even simpler, like, you know, the ability to do radiant heating in applications where that can work well, and allow even variation of environmental climates from one space to another, as the people are diverse and have sort of different needs and preferences, instead of a massive over complexified system. The ability to allow a little bit more local control and actual interaction with the environment, like, you know, again, radical things like opening windows, like radical response to humans who work in places. Ursula.
I mean, just a little add-on. I mean, we did investigate the performance of all the campus buildings during COVID and after, and I mean, and nobody was in the buildings for months on end. And in the end, the savings were like between 20 and maximum 40%. Because basically everybody, the building management systems run on holiday schedule, and that, I mean, that shows how non-smart all these buildings are. They have all building management systems, but I think we're still a way off to really shut down the air handling if there's no user in the space, or really minimize it. So I guess there are quite a lot of studies like that basically show that we have a lot to gain if we. So it's about the user, yes, but it's also about energy savings that can be achieved if the systems are only operating if the user is actually in the building.
And operate a campus, and we saw something exactly as you're describing, Ursula, as well, on the campus that we operate, next to no savings, which sort of blew people's minds. It seems counterintuitive at a time when buildings were not wholly but largely unoccupied, because the systems run. Yeah.
I was going to just make one little minor point that I think, you know, we don't like to discuss these things often, but I think as people that are involved, myself, I was involved and continue to be involved in professional practice as well. There is some belief that we have these things called control systems and sophisticated types of you know, HVAC systems and so on that can do all of this for us. But the reality is that all of these are very, very crude compared to, let's say, what we would say as human intelligence. And maybe with AI that might change. But I will say this much: there are certain systems that really should be banned from buildings because they have a track record of having very poor satisfaction rates. So if there was anything that I could do, is I would say, don't ever let anyone install a variable air volume system in a building, because every time I've seen it, both the comfort and the air quality suffer, and people say, who designed this system? And the reality is it's just the industry makes a lot of money selling this stuff. And there's a whole bunch of controls that go with it. But as they found out in the Manitoba Hydro project, they over-controlled, and then they had no way of being able to synthesize the information coming from the sensors. In other words, they're not able to make a controlled decision because at the time they had something in the range of over 3,000 sensors, and no one had ever designed such a large system and didn't know how to prioritize. So it's like being a short order cook and having 75 buses show up at your trying to decide what am I going to do, and they never thought of that. So really, you know, we do have to sort of think of our systems as being very granular, and always the one thing that's very important is that the occupants should be able to control their ventilation, they should be able to control their lighting, and they should be able to control their temperature. These, I would say, are like basic rights of inhabitation of a building. And if you cannot, then you can see how these problems are going to really multiply quickly. So I say that because, boy, I've been doing this for a long time, probably longer than I should, and I've never seen most of these HVAC systems result in satisfactory solutions.
This is a bold future you speak of, Ted. The rights of an occupant to control, I took notes, ventilation, lighting, and temperature. Like that is a radical call to action in a modern building, or many of the sort of modern buildings that we wind up seeing.
Well,
So
if you want to feel at home, if you want to feel at home and being part of something that you would say is your family, I think most people in a household have this right. And I just think that we have to start to think about that instead of having Big Brother say, this is what you're going to do. You're going to live in this temperature regime. But at the same time, I do agree with what was said earlier by Carol. We have to teach people to also modify their behavior. You know, do things like keep a cardigan sweater in your office, you know, because sometimes that's the solution. Put on a cardigan sweater or dress appropriately. Don't wear a shirt, tie, and heavy tweed jacket when the temperature outside with humidex is 45 degrees, you know? That's just asking for the system to do too much work to make you comfortable. So I think we have to also look at dress codes and so on. But really, we do have to still privilege the individuals.
that makes a lot of sense to me. So as we think about privileging the individual, living beings, that brings me to my next question, and I'm going to go to Annie first on this one. Et la question concerne la conception biophilique, solution fondée sur la nature et inspiration. Le modèle des années 1950 du scientifique travaille seul dans un laboratoire isolé n'est plus le nom. Ayant eu l'occasion de visiter des laboratoires comme celui de Ressources naturelles Canada, CanNet, j'ai entendu dire à quel point les espaces naturels, environnement, apportent de la vitalité aux scientifiques et améliorent la qualité de leur vie professionnelle. Cependant, l'intégration des espaces verts n'est pas toujours une priorité et pourtant, ces décalages peuvent réduire l'accent mis par le budget du laboratoire sur l'importance des solutions fondées sur la nature dans le cadre de la lutte contre le changement climatique. Le laboratoire Canada a créé la prochaine génération des centres de recherche scientifique innovants et collaboratifs. Quelle politique pouvons-nous utiliser pour encourager les pratiques et les espaces de rade qui aident à maintenir la conscience de l'espace naturel environnant pour nos scientifiques? Existe-t-il d'autres moyens d'inspirer les scientifiques à réfléchir de manière critique à l'impact environnemental de leur travail et à viser l'excellence dans les pratiques de recherche durable? Quelle approche devrait être intégrée dans les installations et les communautés dans lesquelles elles se trouvent pour que les solutions fondées sur la nature soient mises en œuvre de manière équitable? Annie.
Oui, je vais commencer en revenant effectivement sur les bénéfices dont vous avez déjà mentionné à propos des solutions basées sur la nature. Donc, effectivement, ce sont des solutions qui peuvent aider à réduire l'impact des changements climatiques parce qu'effectivement, bon, la végétation va séquestrer, stocker du carbone, mais ça reste quand même relativement limité par rapport à l'ampleur de toutes les émissions qu'on va avoir. Donc, j'aime quand même mettre un petit bémol là-dessus, mais ça reste que du moins conserver cette végétation-là va être vraiment très, très important, même d'un point de vue de l'atténuation. Mais il y a énormément de co-bénéfices à vivre dans des endroits qui sont végétalisés. Donc, vous en avez nommé quelques-uns, mais évidemment, il y a toute la question de conservation de biodiversité, même dans des endroits très urbanisés, de conserver des espaces végétalisés va avoir un impact très, très important, entre autres de les connecter, ces espaces-là aussi, sous forme de couloirs de biodiversité. On a évidemment la qualité de l'air, autant à l'intérieur d'avoir une forme de végétation qu'à l'extérieur. Et on va aussi avoir toutes les questions d'adaptation au changement climatique, là, de conserver des espaces végétalisés va aider évidemment au niveau des îlots de chaleur. Donc, on le voit de plus en plus avec les toits végétalisés ou les espaces entre les bâtiments. Ça va aider aussi gérer les eaux de pluie. On a de plus en plus fréquemment des épisodes de pluie très, très intenses. Et évidemment, quand on a des surfaces très minéralisées, on perd le contrôle, on inonde un peu partout. Donc, tout ça, c'est vraiment, il y a énormément de bénéfices à avoir ces espaces végétalisés-là. Puis, je reviens sur cette idée de comment est-ce qu'on peut, effectivement, ça peut contribuer à garder la conscience peut-être environnementale des scientifiques. Mais une autre idée que j'ai eue aussi en lisant la question, bien, ça pourrait être, on le fait dernièrement beaucoup avec les questions d'équité, diversité, inclusion, où maintenant les chercheurs sont vraiment, même quand ils vont déposer des demandes, que ce soit dans les organismes subventionnaires ou peu importe, ils doivent vraiment avoir une réflexion sur comment intégrer les questions d'équité, diversité, inclusion dans leur recherche. Puis je pense que ça a fait ouvrir énormément les consciences parce qu'avant, on n'y pensait pas. Évidemment, il y a des chercheurs qui avaient mis en place des initiatives, des bonnes pratiques, ça se faisait, mais le fait d'imposer un peu ces réflexions-là à l'intérieur du reporting ou des demandes de subvention a forcé, premièrement, à faire de la formation pour les chercheurs. Qu'est-ce que c'est? Puis à forcer à réfléchir aux stratégies à mettre en place. On pourrait peut-être faire un peu la même chose avec ces questions. Quel est l'impact environnemental de mes travaux de recherche, peu importe dans quel domaine je travaille, si les scientifiques avaient un peu plus soit dans leur demande de subvention ou quand ils font de la communication de leurs résultats, d'intégrer cette réflexion-là. Donc, comment mes travaux, ma recherche affectent l'environnement et ne serait-ce que du moins d'une façon qualitative, et comment je peux améliorer ce que je fais pour que réduire l'impact de ce que je fais, ou du moins voir comment même ça peut être au service de la lutte contre les changements climatiques ou de la lutte contre de la transition écologique. Donc, d'avoir ce genre de réflexion-là un petit peu à l'image de ce qui se fait avec le DI, je pense que ça pourrait être une façon intéressante de l'intégrer.
Merci beaucoup. So, Carol, I'll turn to you. A couple of really cool points there by Annie, just to do a quick recap. So, we can think about, how important sort of natural spaces and green spaces are inside buildings, whether or not they themselves directly, reduce the number of GHGs. Beyond that, there's a lot of other benefits. So, green space and, as we said in the question, is a biophilic response, but it also can support biodiversity. It can improve air quality for people working in places. It can help reduce heat islands in denser urban environments. And it can assist with things like storm management and water from heavy floods. So just the presence of green and the presence of natural materials inside our design has just a wide range of benefits that we don't often think of. Then Annie said, EDI offers a really interesting perspective, and it's forced researchers to, when they're thinking about putting in a grant application, to think about, what are the impacts of these equity, diversity, and inclusion in their research programs, and any challenge just to think about well, what if we took that same kind of a lens and thought about the effects of nature and green spaces and natural materials in the nature of our programs and our work and our spaces, how profound these things can actually deliver a broader social benefit beyond sort of the immediate thing that is at your core focus. So any thoughts, perspectives that you'd share? And I am interested in Carol's take on this because, and I've said this before to her a few times, I'll now say it in front of the room here. I'm a bit of a fanboy of some of Carol's work. She's leading some of the most important work in Canada in terms of mass timber, which is incorporating elements of nature. They are the design. So, biophilic responses in the presence of natural materials is something that I know you're deeply experienced with.
Yeah, absolutely. I mean, I think I love all the things that you were saying, Andy, about acting responsibly and actually using green spaces and natural systems over, putting the water in a pipe, to actually look at infiltration, to look at the plant material, to look at actually how we actually harness the power of the water, power of the sun, and actually really, really try to re-engage with the natural power systems that are already here powering the earth, and how we can actually see them powering our buildings and how we can see them actually changing our landscapes, rather than putting down more hard surface and then dealing with flood situations. How do we deal with infiltration, and how do we actually deal with cleaning the water through the natural systems that are already there, the sort of bioremediation, really, especially when we live this close to water systems. But the other piece is the social aspect of it and the human aspect of it, and seeing ourselves as part of nature rather than separate from it. And certainly pretty much all of science and scientific research is studying natural systems and natural and structures in nature. So while we want to study that without being conscious of our relationship to nature, I think is actually counterintuitive in my mind. And in terms of the data, I mean, it is there. Studies coming out of both Finland and Japan that speak to the lowering of our blood pressure when we are actually sort of surrounded by natural materials. Duncan, you mentioned biophilia, which is actually just your natural tendency to be attracted and to love natural materials and objects, and I think that this shouldn't be sort of seen as something that is not quantifiable, and I hope that there's more research happening around it to understand how you can actually reduce stresses and reduce and encourage social behavior. And I think as well, in these sort of geopolitical times when we see each other's differences so profoundly to the ends of the earth, that I think that we need more commonality. And I think to see ourselves as natural creatures and to see ourselves as part of nature is part of that. So it extends, in my mind, well beyond just being around beautiful things, but actually seeing ourselves as natural creatures and part of the environment. And you can't deny the impact we're having. I mean, this is the age of the Anthropocene, where we are the biggest impactors on the natural landscape. And just in terms of greenhouse gas emissions, human-made greenhouse gas emissions, the statistic is about 40% for buildings, but as an aggregate, cities are more like 70%. And so if you put all of the systems that we are impacting into the natural environment, it is ridiculous. We have got to change our fundamental systems and actually adopt passive technologies, use the power of the sun, use biomaterials and renewables as much as we can. And I think that it is kind of our duty as human citizens to actually start taking care of this planet better. So I think that there is a piece of this that makes us feel better, but we need to do better. So I think it's both responsibility and actually trying to change our attitudes from an exploitative one to the planet.
Thanks, Carol. Ursula.
I just want to add one point because I'm involved a lot in discussions around densification in cities. And I think we need to move away a bit from the building scale because not every building lends itself to having trees all around. And I mean, a green roof can be done, but in a high rise doesn't really mean very much. So if you're in a dense urban setting, and I think that's what we should do to avoid all the other negative consequences. I would tend to think more of a sort of neighborhood scale, and especially if you talk about equity, I mean, I think access to green spaces is more important, and that often is not cannot be on a building scale, but you should have access to green space, to a park in walking distance. And you can still live in a very dense urban setting. And we had the same discussion on net zero buildings for a long time, which works perfectly nice for sort of single family homes with a big roof for solar. But as soon as you go to high rise, it doesn't work anymore. And so in Europe, it took a long while to say, well, we do maybe nearly net zero, and then it sort of weakened a bit to a kind of more virtual power plant concept. I think you should definitely do something, but I think we need to talk a bit about scale. At what scale the balance needs to be redone, both for energy and also for I think for the whole biodiversity discussion. I think we should talk more of access to green spaces on a specific scale. I haven't seen any kind of harmonized standards around this, but there's of course a lot of discussion around access to parks and so on. And I think it's important to keep in mind, because these sort of the beautiful biophilic sort of high-rise projects, usually they're just for the rich. They're not really very scalable, and so I think the context plays a role in this debate.
In fact, the Natural Resources Canada facility that I mentioned in the question, it's a kind of funny one to mention in this question. It actually sits inside basically a park, Ursula, as you're describing. But the structure itself is a 40 to 50-year-old concrete brutalist structure that does a very effective job at keeping horrible things like light and air away from the occupants of the building. But they can step out of this building that is basically a bunker, the one that I'm thinking of, into this beautiful park that's inside a green belt. So, you know, some things right, other things less so in that particular design, I suppose. This next question is going to be, oh, sorry. Ted, were you getting in on this one? The next one is definitely coming your way because of some interesting things you said before.
I just wanted to say that, you know, you can have your cake and eat it too. And at the Terence Donnelly Center for Cellular and Biomolecular Research at the University of Toronto, we put in a beautiful bamboo garden. And the choice was really, do we sort of do the big fancy lobby that you put inside of these facilities, or instead of spending money on the lobby, the ostentatious lobby, do we put in a space where people can go and, you know, listen to water running and have these beautiful plants and the sunlight streaming through, and, you know, all of the researchers go there and you see people sitting there and they're just meditating. Some of them are having their lunch. It's really lovely. So I don't think we do have to start to think about things like winter gardens in Canada in a serious way. These things become investments in mental health that actually does have a lower life cycle cost if we start to think about the price we're paying for dealing with people's depression and insomnia type of incidences. I mean, so if we're going to be very holistic about it, I don't think these things are luxuries, even though I know the rich tend to put them into their buildings because they can afford them. But probably they're also getting good professional advice that it is good for your health too. But the point is, I think it's for everyone. I think that's one thing we've never thought about very much as Canadians, maybe because we were hewers of wood and drawers of water for so long. But now that we're a globalized world, we have to start to think about that.
Great points. We had a chat before this session, and in that chat, Ted, said a couple of controversial things about the importance of data and actually analytics, which inspired the next question. And it pulls on some of the points that have been raised by a number of the panelists thus far through the discussion. So to turn a vision into something concrete, it requires a lot of detailed work of analysis to make some informed decisions, evidence-based decisions, he says, speaking to an audience of scientists, one would hope. At the parliamentary precinct, where I also work, and with our new laboratories, we do use life cycle analysis to try to weigh costs and benefits over time. We've developed a document called the Repeatable Lab Design Framework that guides project managers in their decision-making process. And it requires, among other things, it requires a GHG options analysis to be completed. So when you look at the design, you actually try to do some modeling and generate some numbers to inform decisions beyond just the immediate price tag. 2 points that were raised earlier. As leaders who do understand well life cycle analysis, can you share any views on how a life cycle analysis approach or data in general around making decisions on buildings and building systems, how that can inform and strengthen our approach as a government to making decisions around buildings? What role would you like analysts inside our system to play in promoting within the construction industry or other sectors, life cycle analysis or data-informed decision-making? Ted, you led the call to action on let's actually have data on things, so I'll turn to you first.
Okay, I'll try to be very brief. I think we've done a very poor job in the 20th century of gathering much evidence about how buildings perform. We're in the 21st century now, and we're almost a quarter of the way through it, and we don't seem to have improved that very much, but it is starting on a broader scale. I'm starting to see more of it. Most of it is overseas, where they seem to routinely say, well, maybe we should do something radical. We should actually go and interview the occupants of the building to see what they think of their building. And it's like, wow, can you imagine that? It's like that's like the waiter in the restaurant coming by and asking you if you're enjoying your meal. It's something we would just normally expect someone to do. But we don't here. In fact, we just do it and we move on to the next thing. So I think that is one thing that has to become really important. And I don't think that we should be giving ratings on buildings. I don't care whether it's a LEED or anything else, based on what is promised at the design stage and comes about from either life cycle analysis or, for that matter, energy simulations. These are all predictions of performance. I think you should, reward actual performance. We should do the same thing we do in the Olympics. It's how fast did you run that race on that day? That's what you get the medal for, not for your CV going into the Olympics and the promise of your performance at the Olympics. And we're watching all kinds of things now. There's a World Series in baseball. The best team is going to win, and everyone's going to see why. And I think we need that kind of evidence-based look at building performance so that we understand which are the great buildings from the inhabitants' point of view, also from their life cycle performance. But let's face it, we're not gathering data in a way that's useful to building scientists yet, but I would really hope we start to do that.
Great. Annie, did you have
Yes, of course, LCA I think is very essential, and we said it earlier, answering previous questions. So to make sure that we really prioritize the actions that would lead to a significant impact in terms of decreasing the environmental footprint of the buildings, and as Ted said, we often rely on certification schemes such as LEED, but sometimes it can be dangerous. Yes, of course, it's a prediction, but also it's not really quantitative and it's not contextual. So sometimes in a certain context, if we rely only on LEED, we might not take the best decision and maybe put efforts on something that would have a poor impact in terms of decreasing the environmental footprint. And in terms of what could be done in policies in order to promote the use of LCA? Well, of course, we often talk about like exemplarity of governments. Inside the government itself, for instance, in terms of procurement, maybe that there could be more sustainable procurement processes that are used in terms of just buying materials, for instance. And when you build, of course, when you construct buildings, like LCA could be systematically used. Sorry, that could be something that could be done. And also, like we see more and more environmental product declarations, but some policies also can help promote that in order, like we see it a lot in Europe. Like there are a lot of initiatives in order to make it used in a broader way. So that's why we see much more EPDs in France, for instance, than we see here. So that could be also another idea. And of course, like in policies, we see it more and more. I just have in mind the example of the federal government who just go with its clean fuels regulations, and it involves the use of LCA with the LCA tool and so on, so that we can calculate the carbon footprint of the fuel in order to decrease the total carbon footprint of what is used on the market. So this type of example can be broadened to other sectors too.
So good on modeling and analysis associated with the modeling to inform design decisions. And even better if we actually measure that and learn from it, and award the medals based on performance as well. So a bit of a hybrid approach to analysis and actual observed data and tuning. One of which we've been leaning in on more so, and the second of which maybe we still have a little bit more work to actually observe before we move on to the next. Ursula.
Yeah, maybe just to add, I mean, I think one of the issues with LEED is that there's so many indicators all mixed together. So it's not necessarily the best performance from an energy or carbon emission point of view. And I think there are sort of other standards, for example, the passive building standard, which is pretty easy to grasp, and mostly these buildings do perform pretty well. And I looked at your sort of design framework. I think it's all good. I mean, it shows the leadership role. I mean, 25 years life cycle assessment, net present value, and I think more or less 25% better than building code. But if you look at cities like Frankfurt, for example, they decided in 2005 to only allow passive standard for all municipal buildings, retrofit or new build, and they took a 40-year life cycle. They did a 40-year life cycle assessment, and that of course changes completely the dynamics. And these buildings have been monitored. They do perform well because basically they're just super insulated and have ventilation with heat recovery, and that's it. It's pretty simple. So I think so the ambition of the leadership role of the public sector could be maybe even higher than what you have just now.
Very good. Thanks. So this brings us to the last question that we had. C'est une question qui concerne la circularité et la construction. L'augmentation de la circularité des matériaux dans la construction suscite de plus en plus d'intérêt. La réutilisation des déchets générés par notre économie peut mettre en évidence le recyclage des matières premières et la récupération des bâtiments déconstruits. Le Conseil canadien des normes a récemment conclu une table ronde visant à établir une orientation stratégique sur l'économie circulaire pour l'environnement bâti du Canada, qui s'est appuyé sur le secteur des matériaux, par exemple béton, acier et bois. Nous devons explorer les possibilités de recycler les matériaux de manière non seulement durable, mais aussi sûre et résiliente. Pour les labos, la prise en compte de la déconstruction et de la modularité dans la conception est une méthode de réutilisation des matériaux de construction. Il s'agit de considérer nos constructions comme des sources de matériaux plutôt que comme des structures permanentes. Quel défi cela représente-t-il pour les décideurs politiques qui encouragent davantage la circularité des matériaux? Existe-t-il des exemples réussis des politiques qui ont aidé la construction circulaire à être appliquée ici au Canada? Et peut-être en commençant par le bois. Donc, je vais commencer avec Annie.
Oui, effectivement, puis la circularité, les questions d'économie circulaire, oui, on parle de recyclage, mais ce n'est pas que le recyclage, et ça, c'est important de le garder en tête parce qu'il y a beaucoup de politiques qui peuvent aller affecter différentes stratégies au niveau de la circularité. Donc, l'idée, c'est évidemment d'optimiser l'utilisation des ressources et des matériaux dès le départ, donc dès la conception, et de favoriser tout ce qui peut faire en sorte de retarder la fin de vie et le recyclage, qui est ultimement la dernière stratégie qu'on veut appliquer. Donc, tout ce qui va permettre de augmenter la durée de vie et d'optimiser l'utilisation. Donc, on parlait plutôt de partage afin d'intensifier l'utilisation des ressources. Donc, toutes ces stratégies-là vont vraiment mener vers une plus grande circularité. Euh, euh, Qu'est-ce qui fait en sorte que le secteur de la construction est très peu circulaire? C'est un des pires secteurs. Ben, c'est beaucoup le fait que, par exemple, l'enfouissement des matériaux est vraiment très peu cher. On a beaucoup d'espace pour l'enfouissement. Donc, il n'y a pas d'incitatif nécessairement à réutiliser les matériaux. Et on a aussi le fait que déconstruire reste plus complexe que simplement démolir. Et si on veut évidemment recycler en fin de vie, on doit déconstruire parce qu'on doit séparer les matériaux, ne pas les briser, donc pour être en mesure de les réutiliser ou de les envoyer vers les bonnes filières de recyclage. Donc, il y a beaucoup des questions économiques derrière ça. Donc, c'est sûr qu'en termes de quelles sont les politiques qui pourraient favoriser la circularité, euh, bien évidemment, on peut faire en sorte de soit bannir l'enfouissement pour certains matériaux. On parlait de l'exemple du bois. Bon, il y a des places, entre autres au Québec, dans la législation, on a prévu de bannir l'enfouissement du bois. Bon, ce n'est pas encore mis en œuvre. Il y a encore énormément d'enfouissement, mais déjà là, soit bannir ou du moins de faire en sorte d'augmenter les coûts de l'enfouissement va faire en sorte que toutes les initiatives de recyclage ou de récupération vont devenir économiquement intéressantes par rapport à ce qu'on fait aujourd'hui. Donc, cette idée d'internaliser les coûts de la pollution, c'est vraiment important aussi. Et ça, on peut le faire vraiment de différentes façons. Donc, évidemment, il y a toutes les questions de marché du carbone, mais aussi de rendre intéressantes toutes les initiatives qui vont mener à allonger la durée de vie ou à recycler, donc vont permettre d'aider là-dessus. Évidemment, aussi en termes de politique ou dans nos codes ou dans nos normes, on a certaines barrières. Donc, un exemple qu'on a trouvé, c'est avec certaines recherches ici, c'est quand on veut déconstruire et avoir une plateforme pour récupérer les matériaux, bien, dans plusieurs cas, ça va être considéré comme une matière résiduelle, donc une matière potentiellement dangereuse. Puis il y a des normes environnementales très strictes qui ne favorisent pas la récupération de certains matériaux. Donc, il faudrait revoir ça euh, pour faire en sorte que ben, ces matières-là ne soient pas considérées comme des matières potentiellement dangereuses pour faciliter le réemploi. Donc, ça, c'est des choses. Puis, euh, évidemment, il va y avoir beaucoup d'efforts à faire en termes de... parce que quand on va avec les matériaux vierges, on est à haute échelle, que ce soit le bois, l'acier, le béton, peu importe. Ce sont de grosses usines. On a des chaînes de valeur qui font en sorte que ce sont des gros volumes qui vont promener. Quand on tombe en circularité, ben là, on va avoir, les matériaux sont dispersés un peu partout et là, on va devoir comme faire de la logistique inverse sur des plus petites chaînes, sur des plus petits débits de matériaux. C'est dispersé, c'est plus local. Donc, pour que ce soit compétitif, il faut que ce soit plus local. Donc, il faut revoir beaucoup nos chaînes d'approvisionnement et toute notre logistique. Donc, il y a aussi de la recherche à faire de ce côté-là. Donc, c'est sûr qu'il y a beaucoup de défis. mais c'est des choses qu'on commence à vouloir mettre en pratique.
Excellent, merci Annie. So colleagues, like some really interesting points that Annie raised. She highlighted, for example, basically the economic challenge that plays out in a couple of different ways. And if you think about what kind of policies should we do, any sort of policy that recognizes the fact that right now the economy is set up and supply chains are organized around sort of, to go back to one of Ted's points, hewers of wood and drawers of water in a country still with lots of space, that we're organized around going out there and cutting down those trees, first of all. So anything that internalizes some of the costs or the externalities associated with that, that's the kind of policy measure that could be helpful in terms of encouraging circularity. The other thing that we could do, and I really like this point, Annie, is we could try to get out of our own way. So we could stop having policies that say, well, if you take wood out of a building, maybe that's waste, and therefore maybe that's hazardous material, and maybe we have to make it extra hard and expensive to try to do something with it instead of looking at it as a resource. So a couple of really interesting perspectives there on how we can be thinking about improving circularity, recognizing the value it brings, and removing some of the barriers that we've inadvertently set up that prohibit it. So other comments, colleagues, on the theme.
Okay.
Ted, you're going there.
Okay, we set up a Toronto Circularity Network, which is a joint academic and professional ad hoc organization at this point. But in early discussions, we realized that the same thing that happened with environmental product declarations has to happen for circularity. Right now, we don't have what I would call a circularity index for any given product. You want to know, okay, what is the potential for this product to be either reused or recycled? So just to give you an example of things that are at two ends of this extreme scale, a dried up old piece of caulking or some flaked off paint, you realize that you're not going to do anything with that. On the other hand, you have something like a cobblestone, a completely reusable. We have all kinds of areas in Toronto where we've taken the cobblestone from here, put it in other intersections, people are walking over it. It has a tremendous reuse. Its circularity index is so much higher than the dried up piece of caulking that really you can't do anything with. The only thing you can do is maybe burn it in a waste to energy facility. So my point is, we have to now understand that about all of the products, and that way designers can make decisions about what products they want to put into buildings. But it's very difficult to make policies if you don't have a way of measuring the circularity potential of different materials, assemblies, and modes of construction. So until we get to that, so again, you could see I'm a building scientist. I want to take a very bottom-up approach to the evidence to understand it. And then you make this decisions. You know, people look and say, well, what happens when, I think most of anybody has had this experience in renovation. Think of the difference between taking something like ceramic tile and sticking it to a wall. You'll never get that tile off the wall without destroying it, versus something like hardwood flooring that's nailed in, but which can be, with people that know how to disassemble it, take it out. And I've seen hardwood flooring go from one building to another, refinished and reused, and have another life. So just even basic processes of how we stick things together and whether you can ever take them apart again become important design considerations when we're specifying roof membrane assemblies and so on. So we're at an infancy right now, but I think that if we were to devote funding to the type of research that we do have to do, and eventually mandate both EPDs and circularity indexes for all construction products, that then we'd be able, I think, to make good policies and design decisions.
Thank you. Ursula, and then Carol.
Yeah, I mean, I think one key is the information at the right time and right place. So if you talk about urban mining in this age of building information modeling, I mean, I think we need to move towards these sort of building material passports that are discussed, they should be much more harmonized than what we're seeing right now. But I think that's the first step to localize the information. And if you know what is inside a building, and it could be the construction, but it could also be all the interior. I know real estate people here who look for old doors, but it's pretty hard to find that information and to be at the right place when a building gets demolished. You could still take out at least some parts of the internal construction. So these kind of material passports made available, with information made available widely to people who want to take it up, is probably a good step. And I think we're moving there with all this building information modeling.
Thank you. And Carol.
Yeah, I just liked a great conversation, and I wish I had the full translation, Annie. I was trying to keep up, but there was a moment where you talked about burying wood, and I need to follow up with you on that legislation that you were talking about. But I mean, I think that the conversation needs to grow as well. Again, this is sort of nascent, but it's an exciting time, right? Because it's like new technologies, new systems are coming into play, this is happening all at the same time, when things like AI and electrification and robotics and everything is actually just happening at the same time. There's a potential for larger systemization of the production of materials. And so we can talk, of course, about deconstruction and reuse, but also just how do we use waste material from one industry to actually kind of inform another industry, and how do we stop producing as much but enable new industries, like something like aluminum, which is the alpha predator in terms of carbon intensity, is infinitely recyclable. If we had the processes in place to take the window frame from that destructed building and reprocess it to become a new window frame, then it's a zero-sum game, especially if we're using a clean grid. And then to actually look at the larger sort of carbon profile around everything that we're using, because the profile of a 2x4 that's milled off of a clean grid and a 2x4 that's milled off of a dirty grid are two different 2x4s. So I think it's just what we need as designers, I find anyway, is the data. So, call to researchers to actually help to provide us with the data and the information so we can make wise choices. And I think that industry-wide, I'm looking forward to the interface between, some of the natural products, the biosystems, and the waste reuse in new materials, so that we can actually really just see a whole new way of building and a whole new way of looking at building materials. And that may be like 100 years in the future or something, but this is the time. This is the time of awareness and awakening. So I just actually think that, it's the opportunity now to actually start looking for these opportunities for larger system change across the material use and reuse.
Thanks, Carol, Ursula, Annie, and Ted. I really appreciate what you've brought to this discussion today. It was the discussion that I was hoping to have. I couldn't have scripted this way, but where it went for me is it went to sort of the biggest systems thinking about what we're trying to do, and connected it in the most tangible way to exactly what is and what should and what could a building be, especially for scientists, with a particular call to action for those who do work for the public good towards the future, studying complex systems, to look at a building and to think about, as a number of you have said during this discussion, participating in the design process, which is part selfishly, this is my agenda, in our Laboratories Canada program. Think about engaging substantively when we get into shaping what that building will be, and engage with it from a design point of view. Look at the building, unlike the way that we have treated buildings generally, which is a container that you either get to be in or you're stuck in, depending on how good or bad it is. But no longer a neutral thing, something that's actually a part, almost like a living system, and an extension that enables you to do the things that you could do better. And thinking about the environmental impacts of that building. If we're calling on and we recognize our scientists as people who lead, how can this building that is not just a neutral container, but is something that is a platform that helps them do what they're doing? How can that help exemplify their leadership in building a better world for tomorrow? And how can we look at and think about the building itself in terms of making buildings and structures better and more sustainable, in Canada, but well beyond our borders as well. So to each of you, a great big thanks for going from the minute up to the grand, and challenging us to do the same, and seeing our interactions with buildings and expecting more of our buildings in a larger context than that, the reductive way that we're used to thinking about them as kind of benign or not so benign containers for our activities. I've run us 1 minute overtime. So since we're already over time, any closing remarks from anyone else here? Any dying closing thoughts that you'd like to make? I've already run us into the time ditch at this point, so in for a penny, in for a pound. Not seeing a lot of nodding heads or hands thrust up. Thank you so much for your time. I enjoyed it very much, and I look forward to speaking with you each again. Bye bye.
Thank you.
Bye-bye.
Bye-bye.
Thank you.
Bye.